Welcome to India's most comprehensive e-learning platform, BYJU'S Exam Prep. And also, special welcome to all ECE as well as electrical and instrumentation students for this session, which is exclusive, very exclusive in control system, that is complementary root locus. From long back, so many students have been demanding continuously about this topic because even if you refer any of the resources, you will not find the accurate information related to complementary root locus. That is the reason why I came up here to explain the concepts related to complementary root locus from the basic level to the required level. After finishing this session, trust me, you will clearly understand what is the meaning of complementary root locus. After that, you will not require any shortcuts and it's very easy to remember and no need to hustle these things. Clear? So let's get into the topic, but before that I would like to inform you about this MSQ series which we have started recently. I hope you all people might be knowing this one, right? As you know, the portion of MSQ questions in the GATE paper is almost very high, right? So that's why we came up with the MSQ series. We have already conducted the sessions on MSQ series in many of the subjects. Those students who missed this subject, who missed this particular session, you please go and watch the MSQ series on multiple subjects, okay? Right, moving ahead, right now one of the great section is going on, that is mass marathon session. As you all know, especially the GATE aspirants, that mathematics plays a dominant role in the GATE syllabus, right? So that's why three legends from BYJU'S Exam Prep, they came forward and to take the class on mathematics and how to score. In fact, they will cover almost the total syllabus, which constitutes nearly 13 marks in just matter of 2 days, right? So obviously you can note down the dates here, whoever is very interested. So please kindly utilize the service provided by these three legends. Now moving ahead, for 2024 students, obviously you can find the scholarship which may be very useful for you to prepare for the GATE in the best possible manner, right? So moving ahead, these are my credentials, of course, for the new students who are very first time to the channel, BYJU'S Exam Prep channel. You all can find my credentials here, but without wasting the time to explain about my credentials, let me quickly go to the topic, that is complementary root locus. I know that most of you are really waiting for this. What we do is, I will explain first few minutes, just 5 to 10 minutes about the root locus and what are the things you are missing in root locus, because everyone by this point of time, you already know what is the meaning of root locus, how to construct the root locus, what are the different steps you need to follow, everything you know very well about this, right? Because you almost reached at the verge of your preparation and going to write the final examination, right? So Ranjan, good evening Ranjan. So what I do is, first let me cover in a quick time about the root locus and then I will discuss the complementary root locus, and I will also show you that how people ignore the complementary root locus and what it plays the dominant role in the GATE examination. Clear? So likewise we will go ahead, but before going to complementary root locus, as I said, first of all, let us try to understand the definition of the root locus clearly and decode it, because most of the times the students study the root locus definition from here and there and finally they will go into gamble it and they will not understand proper definition. Now let me explain that. Let me take the privilege to explain that. So root locus, basically the locus or the migration of the roots of the characteristic equation in the S-plane is called as a root locus. Simple, it is basically a locus. Locus means what? It's a path, right? Locus means it's a path traveled by the roots of the characteristic equation or poles of closed loop control system in S-plane, right? So as you all know, what do you mean by S-plane? So I don't require to explain again about the S-plane. So how the roots of the characteristic equation are following the path in S-plane, that particular path is called as a root locus. But the problem here is, who is defining that path, right? That is more important. Now let me go to the next definition. Either you can go with the first definition, but the second one is more accurate. The root locus technique is a graphical method. Try to understand that. This is not a physical approach. This is a graphical method. I repeat, this is not a physical approach. It is a graphical method, right? So for sketching the locus of the roots of the characteristic equation in the S-plane as a design parameter of the corresponding system is varied. Clear? So that means more or less both of these two definitions are explaining the same point. But in the second definition, it was clearly mentioned that it is a graphical method to sketch the locus of the roots of the characteristic equation in the S-plane as the design parameter corresponding to the system is changed. Now the question comes, what do you mean by design parameter? Correct? So this design parameter may be anything, right? So a lot of parameters will be there when we are dealing with the mathematical modeling of the system, especially in control system. But for yourself, right, so up to classical control theory, especially as far as the gate syllabus is considered, let me confine only to the controller gain, which is called as a K, correct? So K is considered as a controller gain. As you all know, in fact, most of you know about this one, right? So how would be the classical or closed loop control system looks like here? So hope you remember this one. If you take any closed loop control system, so let me take this is plus here and let me take this is minus here. As you all know, this would be simply considered as R of S here, that is the input, and for a closed loop control system, we can have a controller gain here K, and this is G of S. I know that you all people know this, but there is a lot of meaning involved in this. So please allow me to explain everything continuously, completely. Then you will not require to remember anything. Otherwise, if you don't study properly, then you have to require, or you require a lot of things to remember and mug it up, right? So let me go ahead. So as I said, K into G of S is there here. Of course, we do have H of S, which is considered as a feedback gain here. So let me write down H of S. Obviously, at the end, C of S will be taken out here. So this is considered as a classical control system, isn't it? This is considered as a classical control system, closed loop control system. If it is a closed loop control system, what would be the transfer function of this one? Closed loop transfer function could be written as C of S divided by R of S. Of course, it could be written as K into G of S, right? K into G of S divided by 1 plus K into G of S into H of S. And people do call the denominator of the characteristic equation as, the denominator of the closed loop transfer function, it is considered as the characteristic equation, correct? So therefore, I can write down clearly the characteristic equation as 1 plus K into G of S into H of S equals to 0. Correct? This is called as a characteristic equation, and every one of you know this one, right? So those who are watching this video or watching this live session, they all know that this is called as a characteristic equation. Now what root locus says is, if at all, if you change the value of the controller gain K, then the roots of the characteristic equation will change their location in the S-plane, right? And then we will connect all the locations of the roots of the characteristic equation to find out the path which is called as a root locus. Clear? So now what would be the values of K that can be changed mathematically at least, right? So can you please tell me, Ranjan, what would be the values of the K? So K can be anywhere between minus infinity to infinity. That means this is the value of K mathematically that can be changed from minus infinity to infinity. Not only K, generally any parameter that is there that has the values from minus infinity to infinity, isn't it? Right? So most of the students, they study that the definition of the root locus as the locus followed by the characteristic equation roots when the value of K is changed from 0 to infinity. That itself it is wrong statement. That itself it is a wrong statement. K can vary from minus infinity to infinity mathematically. Don't argue with me, physically it is not possible. There are many things that comes physically, but mathematically K can take the value from minus infinity to infinity. Keep this in your mind, right? So yes, Jeevan, right? Now the most important thing is, if K is varying from minus infinity to infinity, can I write like this now? So ideally the K can vary from minus infinity to infinity, right? So that is mathematical way. Right? So now I will write in this way. So please see here, K can take any value from, so suppose let us take like this, right? So minus infinity to 0, right? One session, and additional to that, so let me take K 0 to infinity. Of course, I can break this total interval into two sub-intervals like this. K can vary from minus infinity to 0 as well as 0 to infinity, right? Jeevan, you are absolutely right, no problem. You please mention your comment in the chat box, right? So people do call, if at all the value of K is changing from 0 to infinity, people call this as a direct root locus. Clear? DRL. Hereafter DRL means it is a direct root locus, and here minus infinity to 0, then people do call whatever the root locus plot you get in the S-plane, that is called as a complementary root locus. Hereafter, whenever direct root locus is there, I mention that as a DRL, and whenever if it is a complementary root locus, I mention this as a CRL. Then immediately a lot of students, they get the doubt, how is it, sir, we have studied only this, and how come this come into the picture? That is where most of you are not going to study properly, right? And a lot of sessions I have seen, and even the YouTube sessions, even the materials, everywhere wrong information is provided. That's why I came forward to explain this. If you are with me till the end of this session, I am very sure next time you can teach the topic of complementary root locus. Okay, so hereafter you should remember only one thing, right? Complementary root locus means the gain of the controller will take from minus infinity to 0. Simple, right? Later it comes, whether it is a positive feedback or negative feedback, that is a different story. But first of all, CRL stands for minus infinity to 0. Clear? Then CRL, so then this, what is this one here? So this is actually nothing but complementary root locus plus and direct root locus together. It is called as a complete root locus. Clear? So please keep this in your mind. This is called as a complete root locus RL, right? So most of the times in the exam, they directly put a question like draw the root locus plot. If they simply say draw the root locus plot, this is considered as a root locus plot. Clear? If they don't mention anything, draw the root locus plot means obviously this is considered as your generally used root locus here. Clear? So I hope I have conveyed the message. Jeevan as well as Ranjan, both of you mentioned in the comment section. Have you understood first what is the difference between complementary root locus and direct root locus? Yes or no? If it is yes, then we will go and see how the complementary root locus and direct root locus both are different for a single system. That will be very interesting game. So please see here. So let me take a simple case. 4 cases I will take. And with these 4 cases, you yourself will be able to find out what are the different ways, and you don't require to mug up any rules. Trust me, it is very, very easy. Just remember this one. Clear? Yes, it also depends on the feedback. I will tell you, right? So, Jeevan, that is where the mistake. Most of the people, they think that it depends on the feedback. But basically, the complementary root locus means the root locus what you are going to sketch from minus infinity to 0. But that will disturb, that can be connected and that can be converted in understanding with the feedback. Please hold for some time. Don't worry about this. At the end of this session, you will really understand what is the logic, why people say that it depends on the feedback. Okay, that is not the fundamental point. I will tell you the fundamental point. Later you can connect it to anything what you want. Okay, right? Good evening, Hemant. How are you? I am seeing after a long time, right? Yeah, good evening. So now you see, draw the root locus plot for the below system. Now when I say root locus plot, by default it would be considered as a direct root locus if nothing is mentioned. But let me tell you, I am using negative feedback first. Okay, so this is a negative feedback, and also I am giving that the k varies from 0 to infinity. So that means it is a positive value of k. Now let us sketch the root locus without worrying about the complementary this and all. Let's straight away use the basic mathematics and calculator and draw the root locus. Don't look at any other things. Let's go with the basics. Clear? So if k is varying from 0 to infinity, can you please tell me what is CLT of here? C of s by R of s. G1, please hold for some time. You will understand why I mentioned that. How the things will be connected to the feedback. Please hold for some time. Don't come to any conclusions right now. So this is equal to k into. So what can I say? K into s minus 1 divided by s into s plus 3, of course, right? S into s plus 3 whole divided by 1 plus k into, of course, s minus 1 divided by s into s plus 3. Am I right? So now what would be the characteristic equation from here? Usually the denominator would be considered as a characteristic equation, right? So therefore let me write down characteristic equation here as s into s plus 3, s into s plus 3, right? I think what we do is, let us, yeah, it's fine, no problem, s into s plus 3, that's fine, s into s plus 3 plus k into, of course, k into s minus 1, that is equal to 0. Clear? So if I simplify this, what you will going to get characteristic equation? This will become like s square plus 3 plus k, of course, into s, and then minus k, that is equal to 0. This is what exactly you will be getting if you solve till this point. Correct? So s square plus 3 plus k into s minus k equal to 0. Two things you must understand here. I told you that this is negative feedback, correct? This is negative feedback. So please keep this in your mind. And also I told you that the value of k is varying from where to where? 0 to infinity. Please keep these things in your mind. Whether it is a direct root locus, complementary, that we will see later. Okay. First, let us sketch the root locus from the fundamentals here. Fundamental says here that, so let's consider the characteristic equation once again. What was the characteristic equation? Sorry. S square plus 3 plus k into s. S square plus 3 plus k, of course, into s, and then minus k, right? So equal to 0. Now I will ask a simple question. Let us change the value of k, and s1 here and s2 here. There will be two poles because it is a second order system. Now change the values of controller gain, as it was mentioned that it can be changed from 0 to 0.1. Let me take 0.2, and maybe you can take 100 here, and you can take 1000 here. So these 5 points, then you will not get any doubt. Please, 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 I repeat here, after this you need not to remember anything. So please see. So when I substitute k is equal to 0 here and solve this equation, substitute k is equal to 0 and solve this equation, what are the poles you will be getting? 0 and minus 3. Am I right? 0 and minus 3 you are going to get. Now take your calculator and substitute k is equal to 1 and see k is equal to 0.1 and see what will going to happen really, right? That will be very, very interesting. So please do along with me, then you will not get any mistake here. 1 and then 3.1 here. So 3.1 and then minus 0.1 here, right? So let me write down here, yeah, minus 0.1 if I substitute, then obviously you will be having like 0.032 approximately, and then it is minus 3.13 here, right? So 13 here. Now without any doubt, let's go for 0.2 here, right? So if you go for 0.2, let me show you what will going to happen here. So this is the beauty of mathematics, I would say. So it is 3.2 I could say, and then minus 0.2 I could say, right? So the values will come, right? So this will be 0.06 here, and then, right? So minus 3.26 here, clear? Minus 3.26 here. Now you can, if you want, you can draw for this and draw for this and keep these values here. Okay, that is up to you. I don't limit you, but you can understand when it reaches to almost infinity, right? One of the root will go for very high value, another root will go for, you know, s is equal to 1. If you want, you can check that one, right? So let me tell you clearly. Suppose if I keep infinite here, this value, right? So this value will almost reach to 1 here, and this value will go for minus infinity here. Clear? Minus infinity. This is the way. Now sketch the root locus here. Don't worry about any other things. Don't think about that negative feedback, positive feedback and all these things. Just go with the basic mathematics and see what will really going to happen here, right? So this is a S-plane here. So let me take here, yes, right? So this is sigma, I would say, and this is minus sigma, as you all know, and let us not use these things here, right? So because we have limited space here, as you all know that this is a S-plane. So let me simply put it here as a j omega and minus j omega. Can you please see what are the poles location? When s is equal to 0, we have one pole at 0 and minus 3, right? One pole is at 0 and another pole is at minus 3, right? And there is a 0 here, open loop 0. Where it is? Open loop 0 is there at s is equal to 1, right? So s is equal to 1, let me take here. So s is equal to 1, right? Now relax. See the way how this root is moving here, how this root is moving, right? It started from 0 and slowly gone to the 0.032 and 0.06 and all the way to 1, right? So can I say that this is started from here, all the way this is traveling like this? Of course, right? So it is traveling and closed at that point. Am I right? And what about this one, right? Minus 3. Look at minus 3 pole. So when the value of k is traveling from 0 to infinity, now this value, this root locus, in fact this root is traveling in this way till the minus infinity, correct? So this is root locus, simple. Is it clear to every one of you? Please mention in the comment section, guys. So a lot of students are there, please mention in the comment section. This is considered as a root locus, right? Therefore, as we have changed the value of k 0 to infinity, I can say this is the root locus plot, especially when we deal with the negative feedback and negative feedback, and the value of k is actually varying from 0 to infinity. Now we will see what will going to happen if the value of k is taken from minus infinity to 0. right? So just again take the same thing, and now once again what would be the characteristic equation for this one? Same thing what we have done earlier. So all the steps are same here, right? So let me take all the steps same here. Then s square plus 3 plus k whole into s minus k equal to 0. That's why I told you that once you remember the basics, once you go with the basics, everything is easy, trust me, right? So therefore if you go with the characteristic equation once again, right, so it could be written as s square plus 3 plus k whole into s minus k. Of course this is equal to 0. Now again start playing the game with the mathematics. Now let us take the k value here, and let me consider s1 here, and let me consider s2. I am very sure now you will enjoy a lot, and it takes some time, but you will really appreciate me once I complete this one, okay? So because I know what will come in the future, right? So please hold on. So here let us keep k is equal to 0 and k is equal to 0.1 as I said, and keep k is equal to 0.2, and maybe if you want you can keep k is equal to 1000 and keep infinity also. Clear? Now relax. Substitute k is equal to 0 here. If you substitute k is equal to 0, once again you feel that this will come 0 and this is minus 3. No doubt about that. Now k should be varying from where to where? I told you that this is once again, in the second case, this is going to be negative feedback, right? So this is negative feedback. Once again this is negative feedback. But let me change the value of k now between 0 to minus infinity. Clear? That means the negative values of k I am looking at, and see what will going to happen. Minus, minus and minus and minus infinity, right? Now put k is equal to minus 0.1 here. So every one of you do along with me, then only you will understand. Otherwise it's waste of time. So please be with me till the end and do along with me, right? So 3 plus 0.1, that is going to be 2.9 here, 2.9, and last one what it will be? 0.1 simply, right? So because minus minus it is plus. So I am getting here as, yes, now see the beautiful point here. The way how this root is actually traveling now, it is coming to the left side, minus 35, minus 0.035, and this one is becoming like minus 2.865, right? So 865, wonderful, right? Now don't stop here, let's continue here still, right? Yes, so again 1 and then 3 minus 0.2, 3 minus 0.2, that is 2.8, very nice, and then plus 0.2 here. Well, then you will going to get here as, see, you are getting like minus 0.073, right? See the way how it is coming. And what about this one here, right? So minus 2.72 here. Excellent, minus 2.72. Now let me ask a simple question here. So let us take k is equal to 1 for time being, okay? So let's take k is equal to 1 and see what will going to happen. Minus 1. So if you take minus 1, right? So obviously this is going to be once again, yeah, yes, one second, right? Yeah, so 1 and then 3 minus 1, that is equal to 2 here, and then again plus 1, right? So obviously this is equal to minus 1 and 1. So minus 1 and 1, this is coming like minus 1 and 1. I think we need to take one more value here. Please allow me to do everything clearly, then only you will be really understanding and appreciating me. So just let me go with, right? So we have done with the minus 1 also. When we done with the minus 1, 1 came to be minus 1 and another one is coming like 1 here, right? So minus 1 and 1. So can we go one step ahead and see what will going to happen other values of k? So let us take k is equal to some 1.5, minus 1.5. If you want you can take minus 1.5. If you want to take, you can take plus 1.5. But what I would like to say here is, if you want you can sketch the plot now itself and see what exactly the things that will going to change here. Then you will really appreciate me. So please see here. So now you see this is what is going to be your j omega plane. So this is j omega plane, and you all know very clearly that so one pole is here, one pole is here, and one pole is here, minus 3, and there is a 0 here. So 0 is at 1, right? Now you see one pole is actually taking towards to the minus 1, right? Minus 1. Maximum it is going to be coming to minus 1 here, and one thing, right? So I think it is not better to write this as of now, right? So let me explain the remaining thing and then we will come back to that, right? So see here. So one pole, it started from s is equal to 0, minus 0.035 and minus 0.07. What does it mean? It is actually traveling in this way, right? And what about this one? Minus 3, minus 2.85 and minus 2.27. And this will be coming in this way, correct? So now you tell me what happened here is this root locus branch and this root locus branch, they will meet together at this point, correct? and this is exactly called as a breakaway point, right? So breakaway point calculation and all, everything we can do in the same way. Go with the basic mathematical approach, you will going to get a correct answer. Now the great thing is, if you still continue, then you will understand, suppose if you keep a very high value, k value is equal to 1000 if you keep, right? Then you will understand 1000 or 10,000 if you keep, you will really understand one of the pole will reach to 1 and another pole will really reach to the infinity, plus infinity, clear? So plus infinity. So how does it mean? Then that means I am very sure after this it will break out like this and it can come like this, and this is also going to make like this, like a circle. And after this, please see here the way how the root locus branches will come now. So this is the way how it will going to come, and then very sure that one will end at 1 and another one will go to the plus infinity here, clear? So plus infinity. I hope it's clear to you. Please respond in the comment section. Is it clear to every one of you or not? Right? And you may ask a question to me, sir, how do you know that? So just change the value slowly. Keep minus 0.1, minus 0.2, minus 1 and then keep slowly. Then you will understand this is the root locus you are going to get. Please mention Hemant and Vanya and Jeevan. Is it clear or not? Right? For some values of k, you will get complex poles here, complex pole here and complex pole. If you want, you can check that one. Keep, if you want, like k is equal to minus 0.5 and look at that what will going to happen. Can you guys please let me know? Minus 0.5, every one of you. So yes, minus 0.5 if you keep, yes, 1 and then 2.5 here and then minus of minus 0.5, so it is plus 0.5. So wait, I think again and again I am getting the same value, right? So once again, yeah, right, this is also coming like minus 0.22 and then this is coming to be equal to minus 2.28. Now I think you need to keep more values here, maybe keep k is equal to 2. Let us see what will going to happen. Just give me 1 second because a very important point is there, that's why I am getting here 3 and minus 2, this is going to be 1 here, right, and minus minus plus 2. So let me make it clearly, yeah. So keep k is equal to 2 here, minus 2. Then you will understand one of the root as, right, so minus 0.5 plus j into 1.32 here, and this root here you will get that minus 0.5 and minus j into 1.32. Now you should understand here, yes, I am right, right? Whatever I have done so far with a great hard work, that is really true. The reason is, see what is the reason. So for when the values of k is taking all the way from negative values, right, minus 1000 and minus infinity. So instead of minus 1000, let me take that when I keep the value of k very very high like minus infinity, then one pole will really reach to where? So plus infinity, and another pole will reach to 1 here, clear? So this is the way how the roots are going to travel. Now what kind of feedback you use? Everyone please mention here. Raviteja and Ganasri Repalle, please mention in the comment section. What kind of feedback we used here? We used negative feedback, right? But we have taken the values from minus infinity to k 0. So that means, let me summarize here. We used the negative feedback only still, right? Negative feedback. But the interesting fact is, we have taken the value, we have changed the value from minus infinity to 0, right? And whatever we got here now, it is called as a complementary root locus, clear? It is called as a complementary root locus, and whatever we have done earlier, this is called as a direct root locus, clear? Direct root locus. That is exact meaning of complementary root locus and direct root locus. But a lot of people, they have gambled in the, even in the YouTube also I have found many of the cases that they are mistake. So let me go with the actual thing here. Now let me go with the third one here. Third one, what we do is, we will take a positive feedback. Let us take positive here and positive here. Then it will be really very interesting game. So please be with me till the end, as I said. So now it is positive feedback, correct? Let me take positive feedback here, and most importantly, let me change the value of k from 0 to infinity, clear? So 0 to infinity, right? Now it would be considered as a direct root locus of the positive feedback. Remember this one, direct root locus of the positive feedback, right? Now moving ahead, what would be the characteristic equation once again? Once again the characteristic equation will be changed or not? Now it will be changed. 1, now it is plus here. So if it is plus, I would be taking here minus k into, of course it is going to be s minus 1 and divided by s into s plus 3. Am I right? So please mention in the comment section. This must be equal to 0. 1 minus g of s into h of s, right? So moving ahead, I can say s into s plus 3, right? And minus k into s minus 1 all the way this is equal to 0, right? So therefore, if you still go ahead, what you will going to get? S square plus 3s minus k. So it is going to be 3 minus k into s, and this is considered as one of the very important question. 3 minus k into s, and what else is there? Minus and minus plus k here, right? So minus k into minus 1, that is going to be plus k. Therefore, if I consider this as a characteristic equation, now again let me use only the basics. Don't go for any conclusions. Okay, so s square plus 3 minus k whole into s, right? Whole into s, and then plus k, that must be equal to 0. This is characteristic equation. Again, let us change the value of k and look at what will going to happen here. S1 and then S2 here. So keep k is equal to 0 here. So suppose if you keep k is equal to 0, once again you will understand that one pole will be at 0, another pole will be at minus 3. No problem. Now relax. Substitute k is equal to 0.1 and 0.2. And as I said, you can substitute like earlier how much we have substituted, right? So maybe like minus 2 here, sorry, plus 2 here, plus 2 here, and then go like that till the infinite and see what will going to happen. Substitute k is equal to 0.1, fatafat everyone. Now you should use your mind here carefully. When I substitute 0.1 here, so 1 and then 2.8 without any doubt here. Oh, sorry, I am sorry. 1 here, and then 3 minus 0.1, that is 2.9. Right, and then what about this one? That is 0.1. 0.1 of course, right? So this will come down to be equal to, once again, minus 0.035 without any doubt, and then again one more value here, that is minus 2.86. Correct? Now go back to again the same calculation here, right? So again keep 0.2 here. When you keep 0.2 here, 1 and 3 minus 0.2, that is 2.8. And there it is going to be simply 0.2. So then if you go for the calculation, what you will going to get here? Yes, minus 0.07, right? And then again it will be equal to minus 2.72. Now it's coming in the mind, right? It's triggering somewhere you, right? So this table is almost like the same table what we got here, correct? Same table. If you don't believe me, again you substitute s is equal to minus 2, k is equal to minus 2 and c. I'm very sure you will going to get minus 0.5 here plus j into 1.32. If you want, you can check that one. Put k is equal to 2 here and see what you will going to get. You will going to get exactly the same table here, and that's the wonder or wonderful thing related to the mathematics. How many of you enjoyed now, right? So that's what exactly I mean to say. No need to worry about the feedback at starting. Let us try to understand the concept and later we will connect to the feedback, right? So now when I keep infinity here, then you will really understand that one of the root will go to infinity, other root will go into plug to 1 here, right? Whether this will go or this will go, that we cannot actually figure it out. But now if I draw the root locus, how would be the root locus will be now, right? Again, if you look at, so where are the poles here now? So j omega axis already we know, this is j omega axis I should say, minus j omega axis, and there is a pole here 0, and there is a pole here minus 3 here of course, and there is a 0 here, that is equal to 1. Now once again, this table exactly it is like this only, correct? So the same table we are having, right? Therefore I can say once again the root locus plot can be constructed like this, right? So this means it is going to come all the way like this, and then it breakouts here and form like a circle like this, right? And then it goes one side, it goes to the infinity, right? And this side is plus infinity, and this side it is the way how it comes, correct? So now you can see clearly when I use negative feedback, positive feedback, right? Positive feedback, and especially when the k value is changing from 0 to infinity, what you are getting here, right? What you are getting. So negative feedback 0 to infinity, it is positive feedback 0 to infinity k is exactly nothing but negative feedback from minus infinity to 0. Clear? So both of these two are same, right? Both of these two are same. So many times what happened is in the GATE examination, they will give like this, correct? They may give positive feedback. They will simply ask you a question, draw the root locus of this. So for positive feedback, direct root locus, positive feedback, direct root locus, what will be this one? This is a direct root locus because k is varying from 0 to infinity. Positive feedback, direct root locus is actually equal to what? This is equal to negative feedback complementary root locus. Clear? Negative feedback complementary root locus. I hope you understood the way how I am connecting here. Now please let me know in the comment section, are you guys following the session or not? I want everybody to answer to my question, so please let me know, are you enjoying this session or not? Positive feedback direct root locus is nothing but negative feedback complementary root locus. After some time I will connect everything and tell you how you can do any question in the GATE examination, but still then please have patience. Now the last combination let me take, again positive feedback here, right? So that means again I am looking for the positive feedback, right? I am taking for the positive feedback, but here I am varying the value of k from minus infinity to 0. So whenever you change the value of k from minus infinity to 0, irrespective of the feedback, we call that as a complementary root locus only. Clear? We call that as a complementary root locus only, right? But let us see what will going to happen there, right? So now, right? So let me go with this, and first of all, keep the characteristic equation once again. So characteristic equation, what will going to happen? Same like what we got here, right? S square plus 3 minus k into s. Of course, here what we will going to have? It will be like k only, right? So it is k equal to 0. Same characteristic equation you will be getting here now. Now moving ahead, if you take this characteristic equation, so many wonders will come now. So please see, s square, once again, s square and plus 3 minus k whole into s and then plus k here, right? So wonderful. This is equal to 0. Now again, think like an engineer, right? Don't by heart anything. Just look at what happens for k and the poles here, S1 and S2. I'm very sure start changing from the value of k from 0 here. Right now we are intended to change the value of k in the negative zone, minus 0.1 and minus 0.2, so on up to minus infinity, right? Now if you keep, for the very first time, if you keep 0, you will get 0 and minus 3, and keep minus 0.1 here and solve this. When you keep minus 0.1 and solve this, then now you will going to get this one here. So 0.032 and minus 3.13. So please see here, all of you, 0.032 and minus 3.13 here. If you want, you can check that one, right? So write immediately, go for another thing, right? So go for k is equal to minus 0.2. Any one of you, please mention in the comment section 1 and 3 minus of minus 2, so it is 3.2, right? And then k you have kept like minus 0.2, sorry, once again, so minus 0.2 here, right? So yes, this will going to come now as 0.061, and of course the next one is going to be minus 3.26. Continue like this, then you will understand that one will go for infinity here, one of the root, just go over very higher values of k. When you go for higher values of k, then you will understand that yes, one root, technically this goes to infinity and this goes to 1 and this goes to minus infinity here. Now how would be the root locus plot for this? Just think logically and tell me how would be the root locus plot. By this time you should understand what I am doing here. It is j omega and this is minus j omega once again. Now let's take clearly that this here we have one pole 0 and here we do have another pole minus 3 and here we have 1 0 also, right? Now see the way how this pole is traveling. This pole started from 0 and going to infinity 1, right? So this is the way how it's going on, right? And what about this pole? This root of the characteristic equation, which is considered as the second root, obviously it is traveling all the way to minus infinity here. What is this? What is this? Have you understood this one? Right now we have taken for the positive feedback system, right? Positive feedback, but the value of k is technically varying from where to where? 0 to minus infinity, correct? 0 to minus infinity. But when I draw, as it is varying from minus infinity to 0, I could say confidently that this is a complementary root locus of positive feedback. Complementary root locus of positive feedback, correct? But complementary root locus of positive feedback, what actually it is? Go back and see, right? How you see in the first case, right? It is exactly this one, right? So here we have drawn the direct root locus of negative feedback is actually nothing but the complementary root locus of the positive feedback, right? So that means this is equal to the same like what we have studied, that is a negative feedback, right? Negative feedback, I would say, right? Direct root locus. How many of you enjoyed this? Tell me here, how many of you are very clear with the concept now? Very clear. But irrespective of all these things, what should be there in your mind? Whether it is a positive feedback, whether it is a negative feedback, whatever it may be, first you need to decode that. We need to decode whether that is positive feedback or negative feedback, and then we need to change the value of k right? That is the major important point. Now let me summarize this, because I know how much clearly I am explaining. Some students, they want the summary, right? So let me explain summary here, right? So first of all, divide like this, okay? For negative feedback and positive feedback. You already know what is the meaning of complementary root locus and negative feedback. First write down like this, negative feedback and then positive feedback. Clear? So first write down like this. This is easy up to here, right? So negative feedback and then positive feedback. So in negative feedback, when the value of k is varying from 0 to infinity, this we call this as a direct root locus. Clear? Right? And in the same negative feedback, if the value of k is varying from 0 to minus infinity, then we call that as a complementary root locus, provided that we are only playing with one variable, which is nothing but k, right? Now this side you see positive feedback, and when in the positive feedback, when the value of k is varying from where to where, so that is 0 to infinity, again this is considered as a direct root locus in the positive feedback, right? And again, when the value of k is traveling from minus infinity to 0, this would be considered as a complementary root locus. Please try to understand this. So complementary root locus and direct root locus, technically at fundamental level, they don't depend on the feedback. They don't depend on the feedback. They have to depend on the value of the k, range of the k. This is what I was mentioning earlier. G1, I think you are clear now, right? So now see, even if I close this positive feedback, even if I close negative feedback, right? Close this one and close this one. Even now, our basics are hold hood, right? So 0 to infinity direct root locus, minus infinity to 0 complementary root locus. Same thing I have written here. So this theory of direct root locus and complementary root locus, at basic level, they are not, at definition level, they are not going to depend on the feedback, right? They are not going to depend on the type of feedback. Is it clear? All of you please mention. G1 please mention. You are the person who countered me earlier, right? Now let me show you why people say with respect to feedback, because even I have seen some of my students who have studied under me long back, they were also teaching in YouTube and they were mentioning some complex things like negative feedback, positive feedback, negative feedback, positive feedback, like that. Now tell me, so here, is there any similarity between these two? Is there any similarity between these two? That is what we have understood, that in positive feedback, when we construct the direct root locus, it is technically the complementary root locus of the negative feedback. Complementary root locus of the negative feedback. At the same time, in positive feedback, if you take the complementary root locus, or in negative feedback, if you take direct root locus, then this is considered as a complementary root locus of the positive feedback. Clear? So that's exactly it should be here. I hope now it's very, very clear to you, right? Now I will tell you a simple logic why this is coming like this, right? So because you already know very clearly that characteristic equation, look at that characteristic equation, we all know that in the negative feedback we will write like 1 plus k into g of s into h of s, correct? 1 plus k into g of s into h of s, and all our rules will satisfy very happily for negative feedback system. If k is varying from 0 to infinity, we have set of rules, right? Set of rules to draw the root locus, and that is what actually called as a set of rules are already available for direct root locus. Am I right? To sketch direct root locus, we have set of rules if this is the case, right? But what happens? What happens if you are changing the value of k, right? If you are changing the value of k from you know, look at that, from 0 to minus infinity, do we have rules? Do we have rules for this, right? So what are the rules for this? Why I am so much interested in this? Because if I know for negative feedback minus infinity to 0, if it is varying, then that is technically called as a complementary root locus for negative feedback. However, for positive feedback, that is a direct root locus, correct? For positive feedback, that is a direct root locus. Am I right? So that means you may argue with me, sir, for negative feedback, this is a complementary root locus. We don't have any set of rules available for us. But I am saying that if you can construct the complementary root locus for negative feedback, indirectly that is the root locus, direct root locus for the positive feedback. Clear? So that is the reason why you must actually know what happens for this k is equal to minus infinity to 0 also. So what are the rules that will going to change now? So to understand that, first of all, one must really understand what are the set of rules we have for direct root locus, right? But before that, I would like to say, have you remembered when we are having characteristic equation? Look at that. Characteristic equation is 1 plus k into g of s into h of s is equal to 0. Correct? And then our angle criteria, how we have defined? K into g of s into h of s, that is equal to minus 1. And then the magnitude condition is k into g of s into h of j omega. So let me take magnitude condition and phase condition in the next slide. Then you will understand. First of all, I hope this is clear so far. Please mention in the comment section, is it clear to every one of you? Right, I think, let me take here, space is available here, otherwise here also it's fine, right? So characteristic equation, I'm sorry guys, 1 plus k into g of s into h of s, that is equal to 0, number 1. And then take k into g of s into h of s equal to minus 1, right? And if you go for k into g of j omega, so just substitute s is equal to j omega here, then you will understand. Once again, k into g of j omega into h of j omega and equal to minus 1 plus j0, that is also correct, minus 1 plus j0. And then if you take the magnitude condition, it comes like modulus of, once again, modulus of k into g of j omega into h of j omega, that is equal to 1, right? This is equal to 1. Technically that is correct. But have you seen what would be the phase of this one? Phase of this function can be written as, because the k don't contribute any phase, so I need not to worry about that. Phase would be equal to, as we have minus 1 here, minus 1 plus j0 means it can be any odd multiple of plus or minus 180 degrees. That is what you have studied, right? Plus or minus 180 degrees, odd multiple of that. This is what you have studied so far, correct? And this is perfectly valid if you have negative feedback and positive value of k. If you have negative feedback and positive value of k, if you have negative feedback and positive value of k, all the conditions whatever you have studied so far, that is going to be valid, and all the rules you can apply as it is. Clear? But suppose, just imagine a situation that if at all whatever the value of k we used here is negative, right? If it is negative, if it is a negative value, then assume any number, negative number, minus 2 here, and here minus 1 you will be having. Minus and minus you will remove here. Then obviously it will going to become plus here, and this will become plus here. Then you don't require to go with the 180 degrees here, right? So odd multiple of 180 will not come. It may be like 2n pi here, right? So that means now the phase is no longer will be equal to plus or minus 180 degrees into odd multiples. You will be having plus or minus, right? 2q into pi. That means even multiples of pi, correct? Even multiples of pi, where q stands from, right? So any value from 0, 1, so on, this one. Clear? So that means you will be having either 0, first thing, right? Even multiples. This is even multiples. Suppose if you keep 1 here, 2 pi it will become. If you keep q is equal to 2, then it will become 4 pi, right? So what you understood? So if the value of k is negative, even in the negative feedback itself, because we are taking only negative feedback one, right? I am not going to construct anything for positive feedback. I don't require to study about the positive feedback. Why? Because if you know exactly what happens to the negative feedback, this side it can be constructed. That is what I am saying. Just focus only on the negative feedback. Later these things can be connected to this. So therefore, I am still in the negative feedback only, and if the value of k is positive, then whatever you have studied earlier, that happens, no problem. The angle condition will be plus or minus 180 degrees into odd multiple. But if suppose k is negative here, then it will become even multiple, right? So when the k will be negative here, when k will be negative only in the complementary root locus, correct? So that means for complementary root locus, the first thing what changes here is the phase condition. Clear? For complementary root locus, the first thing which changes is phase condition. Still I am explaining only in negative feedback. I am not least bothered about the positive feedback here, because in negative feedback, if I know both the direct root locus as well as complementary root locus, automatically this side I can understand, right? So for k minus infinity to 0, your phase condition is coming like this. As you already know, k minus infinity to 0 is called as a complementary root locus. This means for complementary root locus, the phase is this. All of you please mention in the comment section. I think I have explained so logically. So let me see how many of you understood this. Please mention for my satisfaction in the comment section. Have you guys really understood this or not? Have you guys understood this or not? Ravi Teja, Anirban, Harshavardhan Sai and Anit Kumar and Ganeshri as well as Jeevan. Please mention in the comment section. Is it clear or not, or do you want me to explain one more time? Do you want me to explain one more time? Clear, very good, right? Nice. Anirban is saying clear. Other students? Yes. Other students? Yes, very good. So that means for negative feedback, complementary root locus means the only one thing which will going to change is the phase, right? As the phase is changing, all the rules what we have derived for the direct root locus will change only if it is affected by the phase, right? First thing is rule number 1. We know that root locus is symmetrical about the real axis. Similarly, complementary root locus is also symmetrical about the real axis, because this rule doesn't depend upon the phase. This rule doesn't depend on the phase. So no problem. Next, second rule, look at that. Complementary root locus starts at open loop pole and terminates at open loop zeros. Perfect, right? So if you want, you can go here and see what happened in the second case. Look at only for negative feedback, right? Only for negative feedback, when you see the complementary root locus here, this is CRL of a negative feedback, CRL of negative feedback, right? CRL of negative feedback. What you understood? It started from open loop pole and then terminated at open loop 0 or infinity, correct? So that means second point is still correct even in the complementary root locus also, 0 or plus or minus infinity. If the number of poles are less than number of zeros, number of zeros are less than number of poles, then some of the poles will terminate at plus or minus infinity. That you know already. And then the third one is, look at this, the segment of the real axis exists on CRL, complementary root locus, if the right side to that point, that segment, the sum of poles and zeros must be even. Here, clear? This is a very, very good statement. Look at that second case where we have drawn the complementary root locus here, correct? For this complementary root locus, can you tell me here, this segment we have taken on the real axis root locus, right? So we have taken this on the root locus. I will check this one here. Any point here, if you take right side to this point, how many poles you are having? 1 and 2. So poles plus zeros together, it will be 2. 2 is the even number, but still we have considered this is on the root locus, correct? That means this is on the complementary root locus. This is on the complementary root locus. I hope you understood this one. So this is one of the rule which is different from the very traditional and direct root locus. Clear? So I hope that is clear to you. So I guess I have conveyed the point here very clearly. And the centroid is also same, like sum of the poles minus sum of the zeros divided by number of poles minus number of zeros. That will remain same. And rule number 5, angle of asymptotes. This is very important. And if you remember, for direct root locus, we might have written this as odd multiple of plus or minus 180 divided by p minus z. But here we have used 2q, which is therefore it is considered as an even multiple of 180 degrees divided by p minus z here. Clear? P minus z. I hope it's clear to you, right? Now, break points, and this rule is same like what we have done previously. The procedure is same and understanding that is also same, right? Now, what comes to the most important is like intersection with the imaginary axis, that is also same like previous case. Only here, the angle of departure and angle of arrival. Have you seen in case of normal condition, right? In case of direct root locus, we use here 180 degrees minus this. But here we use 0 degrees minus this, and here we take 0 degrees plus this. Clear? So instead of 180, we will take 0 here. So therefore, you must really understand one thing here. In complementary root locus, whatever are associated with the phase, that is rule number 7, rule number this one and this, whatever is associated with the phase, right? So they will only going to change here. They will only going to change. Rest of all things will remain same. Clear? Rest of all things will remain same. I hope you understood this one, correct? Now I will show you one question which was asked in ECE 1990, right? 1990. Now you will really understand why I am saying that don't look at whether complementary root locus or root locus. Just go and change the value of k and everything try to remember with respect to k. Now read this question, all of you. Every one of you please see. Plot the root locus of this is not negative feedback. They have not mentioned this one, right? I am extremely sorry. it was by mistake given this one. Plot the root locus of the system whose transfer function is given by this, right? And also this is not g of s into h of s, this is the closed loop transfer function. I remember this question. This was a question given in the 1990, right? And they mentioned that the closed loop system transfer function is this. First of all, tell me whether did they mention anything about the complementary root locus here? They did not mention anything about the complementary root locus. If they don't mention in the exam about the complementary root locus, because in IIT, I am also from IIT, right? So usually there is no term we use like complementary root locus, but that is mathematically exist, right? So therefore, please listen here. In the question, there is no term like complementary root locus. They just mentioned root locus. But how we can understand whether we should draw the complementary root locus or direct root locus? That is the question from your side, as they have mentioned that it is a root locus. So I need to consider that yes, the k has to vary from 0 to infinity only. No doubt about that, 0 to infinity only. But look at whether this is positive feedback or negative feedback first. This is positive feedback or negative feedback. This is, overall closed loop transfer function. Therefore, what can I say? This could be written as g of s divided by g of s divided by 1 plus g of s into h of s I can take, right? So can you please make it this arrangement and tell me what would be g of s into h of s here? Or else let us consider that the unity feedback system. For time being, let's consider that h of s is equal to 1. No problem with this, right? Then what would be g of s? G of s would be equal to what, right? So g of s is equal to 1 plus yes. So it is going to be k into, so otherwise you can take this one, no problem, k into s, right? So this is going to be k into s, of course, divided by s square plus 3s, right? S square plus 3s, of course, and then anything else is there, s plus 1, right? So s square plus 3s plus 1. So technically this is nothing but ks divided by s plus 1 into s plus 2, if I am not wrong. So please s plus 1 into s plus 2. This is exactly what it should be, right? Oh, sorry, this is 1, I think. One second. So let us consider like this only. So s square plus 3s, ks divided by s square plus 3s plus 1. Am I right, this one? So, but if you take in this way, will you get this one? No, because we really don't know whether this is positive feedback or negative feedback, right? So indirectly it has to be minus k here and minus k here. If you have like this, then only there is a scope to get that, right? If you have like this, yes, very good, Anirban. If you have like this, then only when I kept this g of s here, you will be getting this transfer function, correct? But now what I mean to say here is, as I am going for the k value from 0 to infinity, let me not make it so complicated. What I presume is here, it might be a positive feedback system. Clear? Why? Because if I take this as a positive feedback system, then I can go with the plus k here. Clear? Then I can go with the plus k here. Now if you take plus k here and resubstitute this and see what will going to happen, let us take the transfer function t of s here. So if you take here ks, right, divided by s square plus 3s plus 1 whole divided by 1 minus g of s into h of s, 1 minus, and this is g of s, so k into s divided by s square plus 3s plus 1, h of s is 1. Now if you go back, what you will going to get, I think s will not be there here, I'm sorry, s will not be there here, so simply s will not be there. So then it will going to become like here, one second, a small modification here, s is not required here. So then just look at what will going to happen here, k whole divided by what you will going to get here, s square, of course this is correct, and then minus 3, perfectly all right, right, minus 3 yes, and then minus 1 plus k, right? So this will be equal to, I think we have, so sorry right? So I think this would be taken now, one second guys, I am extremely sorry, this could be taken as minus k, right? So then minus k, if you take minus k, and it should be 3, right? So it should be 3, s square plus 3s, so I'm sorry, s square plus 3s and plus 1 and minus k, right? Now look at that. So what we will going to get here, so k whole divided by s square plus 3 minus k whole into s plus 1, right? So that means I am very happy to say, yes, this is the transfer function it was given to me, correct? This is the transfer function it is given to me, am I right? This is the transfer function it is given to me. When I rearranged that, yes, absolutely true that if you take this as a g of s, if you take this as a g of s and use this in the positive feedback, yes, then you will going to get exactly the given transfer function. I repeat, take this as a g of s and use that in the positive feedback mode, then you will going to get this transfer function. Am I right or not? Take this as a positive, I mean this as a g of s, and I have used this g of s divided by 1 minus g of s into h of s. I am using in the positive feedback. Then when I rearranged that, we got the same transfer function. What is the conclusion of the story here? The conclusion of the story is, yes, confidently you can take this as a g of s here. You can take this as a g of s, and but invariably the system is given in the feedback, positive feedback, right? So that means this is the transfer function of the positive feedback. Clear? This is the transfer function of the positive feedback. Try to notice now. This is the transfer function of the positive feedback, right? So for the transfer function of the positive feedback, he is asking direct root locus. Why? Because there is no word like complementary root locus. He is saying that plot the root locus. Means for positive feedback, he is asking to plot the direct root locus. For positive feedback, he is asking to plot the direct root locus. What does it mean? For positive feedback, direct root locus means what? For positive feedback, direct root locus is nothing but the complementary root locus of the negative feedback. Clear? Complementary root locus of the negative feedback. Therefore, we should understand here that though the question is root locus of the positive feedback, actually we should make, right, complementary root locus of negative feedback. Clear? Complementary root locus of negative feedback. This is the way how you should understand the things. Don't by heart anything, right? So I hope you got the point now, right? So therefore, how do we sketch the complementary root locus now? So look at this one here. Simple. First of all, you have to, divide this, what are the poles, and check what are the poles you are going to get here. So I think, yeah. So get the positive pole, use all the rules whatever you have discussed so far, right? So first of all, split here poles and zeros separately and then bring them and keep here. Clear? So that means for this transfer function, technically it was mentioned as a root locus plot, direct root locus plot, but that is for positive feedback. Therefore, convert that into complementary root locus of negative feedback. So we must use the complementary root locus steps to develop the root locus plot. Clear? Right. So how many of you understood this? Please let me know in the comment section. Every one of you. I want to understand from your side. Then you may ask a question, sir, how do you know that this is a positive feedback, right? I have just tried with the g of s. I changed this because k should vary from 0 to infinity as it was mentioned like root locus. Clear? So keeping this in the mind, I have changed the transfer function into positive feedback, and then I realized that yes, when I am using this g of s, especially in the positive feedback, I am getting the transfer function what it need to be. Correct? And clearly it was mentioned that you need to plot the root locus, direct root locus, so that the 0 to infinity k should vary. But positive feedback, k is varying from 0 to infinity means this is indirectly means that complementary root locus of negative feedback. Now we must use the rules whatever you have studied for the complementary root locus to sketch this one. Now let me tell you the last one. I think we have done the same thing here, right? This was ECE 2005. Now I will ask a simple question, right? So look at that. Plot the root locus of a negative. Again, it is not given as a negative feedback. I have mistakenly mentioned this, right? It was mentioned like the plot the root locus of the feedback system whose transfer function is given like this. Clear? Whose transfer function is given like this. Now you must really notice this and reconvert whether it should be there in the positive feedback or negative feedback, that is up to you. As root locus plot, as they have mentioned that draw the root locus plot. That means directly I should imagine that yes, k varies from 0 to infinity, correct? K varies from 0 to infinity, right? But whether this can be in the positive feedback or negative feedback, that is important here. So please see here. So you can take g of s. Now can you construct the characteristic equation here? How would be the characteristic equation now? Now the characteristic equation could be written as, generally what you will do, 1 plus g of s into h of s. That is what you will write here, right? But have you remembered this? The same transfer function, if you convert this into the standard form, it will become like k into s minus 1 whole divided by s into s plus 3, right? Whole divided by s into s plus 3. So therefore, what should I write here now? Now if I substitute this, it will become like 1 minus k into s minus 1 whole divided by s into s plus 3. Now you can see here, what is coming here? It is minus sign, right? So it is minus sign. That means once again, I can consider this likely to be mathematically as positive feedback, right? So that means likely to be this is mathematically positive feedback, and for this positive feedback he is asking draw the root locus. That means direct root locus. So what should I say now? For positive feedback, direct root locus is a question. Direct root locus is a question. For positive feedback, direct root locus, which is actually nothing but complementary root locus of negative feedback. Already we have done this one, right? We have solved this question. Complementary root locus of negative feedback. Where it is? Do you have that? Yes, we have that one. So just go back here and see here. That is the second case what we have already discussed, right? So negative feedback, complementary root locus we have discussed. Yes, this is what we got. This is the answer. This is the root locus for this 2005 question. Clear? So that means already we have done this one. Clear? So I hope I have conveyed the message clearly. So the conclusion of the story is if the k value changes from 0 to infinity, that is called as a direct root locus. Clear? If the k value changes from minus infinity to 0, that is called as a complementary root locus. First thing is that is simple. Then look at the given transfer function, and if the question is about direct root locus, correct? But in the transfer function what is given to you, identify that is whether positive feedback or negative feedback one. Once you identify that, yes, the transfer function given in the exam is positive feedback and they are asking the direct root locus, means what? Direct root locus of the positive feedback is nothing but the complementary root locus of the negative feedback. Clear? So that way you can convert the things and then apply the rules of complementary root locus. You will get the answer what is required. Clear? So guys, please let me know, is it clear or do you want me to explain anything here? So I want the response from you. Already we have done. This question is completed. So in fact, this is case 2 of complementary root locus. I have done this. So please look at that. Right, so we have sketched that root locus also. Right, Anirban, sir, can we check the angle condition to understand complementary root locus? Yeah, we can check that one. Anirban, you are right. Right. So how many of you really enjoyed it? And have you really learnt the concept of complementary root locus little bit different way? Right, because you might be watching different YouTube sessions or else different materials. But please let me know, have you really understood anything newly in today's session or not? Right. Amit is saying yes, Amit Kumar, okay, Anirban Nath, please let me know, Harshavardhan and Ganasri, Raviteja, everyone, please mention in the comment section. I'm waiting for yes, right? Yes, only 2 years, I'm really disappointed, right? So maybe some of the students still they are thinking about this, oh, how sir got this one, right? So it's simple, just remove all your, prejudice as well as whatever you have studied the scrap, keep that away, right? Keep that away, everything. Right? Understand the basic point. The basic point is this. Clear? This slide is very, very important. Right? So once you know this slide, what is more important to know is in the question, if they mention direct root locus, but it is positive feedback. Now see here, have you remembered this question? So what the question? Yes, you see here they asked only root locus, means it is a direct root locus, but the system can be converted into positive feedback. So positive feedback direct root locus means it is a complementary root locus of negative feedback. Then change the angle criteria and use the different set of the rules to construct the root locus. Clear? So that's how exactly we do. I hope I have conveyed the message very clearly to you. In case if you have any doubts, please do post me in the comment section. I am ready to answer at any particular time, and those students who want to answer the test series or who want to attend the full length test as well as subject wise test, obviously you can use the platform of BYJU'S Exam Prep. All the way we are here to help you at any particular time, any point of time. So with this I have concluded the session of complementary root locus, and thanks for your patience. And once again I am suggesting and requesting, advising every one of you, in case if you find really any difficulty, please reach me in Telegram group or else post your doubts in the comment section, or else watch the lecture at least once or twice, and keep your pen and paper and calculator with you and solve. Then only you will understand this, what I mean. And if you really taste this, then you don't require to remember anything else. So hope you really enjoyed this session. Let's meet with a new session in upcoming days. Thank you very much once again. Mm.